AP Calculus, Section 5.1, Area Approximation Notes, page 1. All right, we are going to find the area of these figures on this page by using the most basic area formulas, so rectangle, triangle, circle, etc. Pretty straightforward. Rectangle, length times width, so area here is 16 feet squared. Number 2, a triangle here. Probably should have put the right angle there to help you out. Area here, 1/2 base times height. 1/2 times 8 times 2, 16 feet squared. Oops, divided by 2, 8 feet squared. Number 3, trapezoid. We can divide this up into a rectangle and a triangle and do area of the rectangle plus area of the triangle. And that rectangle will give us 8 times 2 or 16 plus this triangle, 1/2 8 times 2, which is 16 plus an 8 or 24 feet squared. The other option here is to remember the formula for area of a trapezoid. And the area of a trapezoid is 1/2 height times the sum of the bases, which would be 1/2 times the height 2 times the bases 8 on the top plus on the bottom 16, and the half times the 2 is 1. 8 and 16 is 24. Same thing, either way, whichever makes you happiest. For this semicircle on top of a rectangle, we'll need to take the area of the rectangle plus half the area of a circle. And the area of a rectangle, base times height, 8 times 2, 16, plus area of a circle, or half a circle here, 1/2 pi r squared. Radius here, right there, and that radius is 1. So we'll have 16 plus pi over 2 feet squared for that area. And looking at this trapezoid down here, again, we could divide that up into rectangles and triangles. We could also just use that trapezoid formula. 1/2 height times base 1 plus base 2. 1/2 heights 2 times top base is 8 plus bottom base 3 here, 8 in the middle, that's 11 plus 1, 12. And so we will have 20 feet squared. Again, if you are more comfortable, feel free to use the area of a triangle plus area of a rectangle plus area of a triangle. For this regular hexagon, we can divide this up into 6 equilateral triangles. And several ways you can handle this. You can remember from geometry that the area of an equilateral triangle is side squared times the square root of 3 over 4. So one of these equilateral triangles is 2 squared, square root 3 over 4, which is just square root 3. So the entire area of that hexagon is 6 of those, or 6 square root 3. If you don't remember that formula, you could go back to your geometry, though you still have to go back to geometry, and you would have to look at this 30, 60, 90 right triangle right here. Hypotenuse 2, so that's 1, and this apothem right here is square root 3. Area of the equilateral triangle then, 1/2 base times height. The base is 2, the height square root 3. Again, there's the area of one of the triangles, and then multiply by 6 to get the total area. Oops, I think you might have been off the page there.